we're going to continue to look at lesson 1-5, solving inequalities with one variable. And my essential question, if you remember from yesterday, is how are solutions of inequalities different from the solutions of an equation? And here's some notes I wrote down in Core 3's notes. So if it looks a little different, Core 1, because I'm using Core 3's book here. So if there are a couple things you remember, you're going to solve it like normal. Nothing different than you solve when it's totally an equation. Reminder, if you multiply or divide by negative, the sign flips. Also, another reminder we talked about is if it's less than or equal to or greater than or equal to, you as a closed. And if it's open, that means it's less than or greater than. So we're going to go over the try-its. If you want to try it alone or with your partner first, that's awesome. And then you can look to see if you got the same answers I did. Or if you don't feel comfortable enough yet to do it yourself, you can follow along with me. So I'm going to distribute this -3 because I'm just going to solve the equation here. And then I'm going to, the verbs is solve and graph the solution. So I get -6x minus 6 is less than 10. And then I'm going to add 6 to both sides because my goal here is to get x by itself. I get -6x is less than 16. Now I'm going to have to divide to get rid of this -6. So I'm going to divide both sides by -6. You should think, okay, if I'm dividing by a negative, I have to flip the sign. So my answer becomes x is greater than -8/3. Or if you want to change that into a mixed number, you're more than welcome. Now, you want to check to make sure that -8/3 is the correct answer. So if you plug it back in, I'll do the check way over here. Your first check is just to see if that answer is correct. So if you take -3 times 2, and then we'll multiply that times a -8/3, and then add 2, it should equal 10. And if it doesn't equal 10, that means mathematically something went wrong. So I'll give you a moment, check that. I'll get my calculator here. So 2 times -8/3 plus 2, and then multiply that all by -3, and it should equal 10, and it does. So that means that my answer of -8/3 is equal, which means I know that's correct. So I can make my number line. Remember, my expectation is to put a 0 and then put the answer in the correct on the left side or right side of where 0 is. And since this is negative, it's going to be on the left side. And then it's a greater than symbol, which means it's open because it does not equal -8/3. Now, we checked it to prove that it equaled 10, but it doesn't. It's only when they're greater than. And then it's going to shade, since this x is greater than, it's going to shade to the right. And please shade on the line. So my second check is to see if one of the solutions here, because there's infinite amount of solutions here, works in the inequality. And I like to pick 0. We had that conversation yesterday. So I'm going to take -3 times 2 times 0 plus 2, and hopefully it's less than 10. This time you're going to put the inequality in there because it should be true. So 0 times 2 is 0 plus 2 is 6 times a -8, or sorry, times a -3 is negative. Let's do it again. 2 times 0 is 0, plus 2 is 2, times a -3 is -6, and -6 is less than 10. So that means I shaded the right way. If I would have checked something to my left of that, then it should be not true. So anything that shaded, since this is a true statement, that means my shading is correct. Again, you can either pause and do it by yourself and then fast forward to the answer, or you can do it with me if you still need some more examples. So 2 times 4 is 8. I'm distributing here. 2 times the -4x is 2 times the -2x is 4x. And then my goal is to get x by itself, so I'm going to take 8 off of both sides. I'm going to end with -4x is greater than -7. And then I'm going to divide by negative. Remember, dividing by negative flips the sign. So it's x is less than 7/4, because a negative over a negative is going to end up with a positive value. Quick check. Again, you can just do this in your calculator. I'm going to write it out so you can see it. So 2 parentheses 4 minus 2 times 7/4 better equal 1. And if it doesn't, then we've done our math wrong, our steps wrong. So I'll put that in my calculator. 4 minus 2 times 7/4, and then multiply that all times 2, and I do get 1. So I know that my answer of 7/4 is correct. Again, you can change that into a mixed number of 1 and 3/4 if you want. I'm going to put a 0. Since this is a positive number, I need to put that value to the right. And then I'm going to work on my shading here. So since it's less than, that means I don't want anything greater than that value of 7/4. And it's not a closed dot because it doesn't equal, but it does equal everything. It's true for everything that's to the left. Okay, and then my check, and I'm going to check 0. So that should be true if I'm checking 0 because I shaded 0. So I'll plug it in here so you can visually see it. It better be greater than 1. So if that answer isn't greater than 1, then we did something mathematically wrong. Put a multiplication symbol. So 4, well, actually, you're going to multiply first. So 2 times 0 is 0. So 4 minus 0 is 4, times 2 is 8, and 8 is greater than 1. So since that's true, then I know that I shaded the right way. So example 2, solve inequalities with variables on both sides. So again, same thing we've done before, same graphing. Okay, we're going to do the same thing as we would do with a equation. So we're going to pick on the little guy. Since 1.5x is smaller than 3.5x, I'm going to take and subtract 1.5x from both sides. So 3.5 minus 1.5 is 2x's. Add your 19 is greater than or equal to -7. Now I'm going to get rid of the 19. So I'm going to subtract 19 from both sides. I get 2x is greater than or equal to -26. Divide by 2. X is greater than or equal to -13. Okay, so checks, and again, you can just put it in a calculator. I'll write it out so you can visually see it. Now this time you're going to have to check both expressions on the left side and right side because it doesn't equal a value. So I'll try this side first. Oops. So, did it twice now. So 3.5 times -13 plus 19. And if I take 1.5 times -13 and subtract 7, they should give me the same answer. So 3.5 times -13, add 19, I get -26.5, and 1.5 times -13, subtract 7 more, I get the same thing. So -26.5, which means that my -13 is the right value. So I can go ahead and make my number line. I'll put my 0 over here to the left since it's a negative number, and put my -13. It's equal to, so it can be, a solution can be -13. That's why you're going to close it, because it can be, like up here, it can't be positive 7/4. So you leave it open, but it can be anything to the left of that. Down here, it can be -13. And I'll read my solution again. X is greater than or equal to -13. Since it's greater, we're going to go to the right. And I'm going to check 0 since 0 is shaded. I'll just leave it that color to make sure it works. Now you're going to check it to both sides. So we have 3.5 times 0 plus 19. So that's, of course, 19, because that'd be 0 plus 19, should be greater than or equal to 1.5 times 0 minus 7. Well, 0 minus 7 would be -7. Check to make sure this is true. It is a true statement. 19 is greater than or equal to -7. So I know I shaded the right way. If you do the check, you shouldn't miss any of these. Okay. Go ahead and do the try it. Again, if you want to go do it with me, you can. If you'd rather just do it by yourself or with your partner, you can do that too. And then you can fast forward to see if you get the correct answer. So I'm going to pick on the little guy here. So I'm going to get rid of the 2x from my left side. So I end up with -5 is less than, that'd be 3x minus 22. I want that x by itself, so I'm going to get rid of the -22 first by adding 22 to both sides. So -5 plus 22 is 17, is less than 3x's. I'm going to divide by that 3. I'm just going to leave it 17/3 is less than x. Now, I don't like to read it like that. It really bothers me. So I'm going to flip it, go the other way, because I like to have my variable on the left. Some people, it doesn't bug me. I like to read it as x is greater than 17/3. But either one of these are correct mathematically. Check. So 2 times 17/3, I'm going to do the left side here first, minus 5, and the right side would be 5 times 17/3 minus 22. Grab your calculators, make sure that works. So 2 times 17/3 minus 5, I get 6 1/3, and then 5 times 17/3 minus 22, I get 6 1/3. So again, that check is just to make sure that value is correct before I make my number line. So I'll put my 0 here, whoops, since it's a positive value. Put the 17/3 over here. Since it's in greater than symbol, that means it does not equal 17/3, but it equals everything to the right. It's greater than. So please shade so I can tell that's the way you shaded. Now, this time, I kind of talked about yesterday, I still like to check 0, which is faster. But when I check 0 this time, it better be false. And it should be false because if you notice, 0 is not shaded. So it's not a solution. So when I plug in 0, it should be a false statement because it's not a solution. Everything that's shaded is an actual solution. So if I take 2 times 0 minus 5, I get -5. And then I get the less than symbol from the original. Remember, going back to your original. And then 5 times 0 minus 22, which is -22. So -5 is less than -22. That is false because -22 is smaller than -5. So this is a false statement, which is a good sign because the 0 is not shaded. Now, if you are annoyed by that, you could pick something that's shaded over here. Like you could put a 5 in here, since 5 would be shaded. If you put a 5 to check it, so instead of the 0, you put a 5, it should be a true statement. So you don't have to always use 0, but if you do use 0, notice that it should be false or true no matter which way you do that. So example number 3. So we're going to now flip the page here. We're going to understand equalities with infinite many or no. So infinite many meaning any solution I want on the whole number line, which means the number line will be all shaded, or no solutions, which means nothing on the number line. It'll be an empty. We call it the empty number line. So we're going to go ahead and solve. So on this left side, I'm going to distribute the -3. So -6x plus 15 is greater than -6x plus 9. Now, most of you at this point can tell, since the variable, or I should say the coefficient in front of the x are the same, that means they'll cancel each other out. But if you want to prove it here, we can add 6x to both sides since they're both the same. Crosses out, you get 15 is greater than 9. Is that true? Okay, so this is a little bit different than before. So it might be better if you just solve it through, since it's inequalities and not equal. So is 15 greater than 9? The answer to that is true. So if the statement, when you get done subtracting out, getting rid of those coefficients with the same variables with the same coefficient and you end up with a true statement, that means that my set, we'll just put 0 here, that means any solution, infinite many, since that's a true statement, anything can be shaded. So this is an infinitely many solution. Now, can you check this? Of course you can. You should be able to pick any number and it will be true. So I'll do my little famous 0. I'm going to take -3 times 2 times 0 minus 5. I should probably scoot that over a little bit. So yes, make sure you have some room. We'll put it up here. So -3 times 2 times 0 minus 5 better be greater than -6 times 0 plus 9. So 2 times 0 is 0, minus 5 is -5, times -3 is 15. Again, put in your calculator if that's easier for you. -6 times 0 is 0, plus the 9 is 9. 15 is greater than 9. Now, you could, just because it's infinite many, check one from the left and the right and just guarantee that it goes both ways. But if you end up with a true statement, it will be infinite many. Solving the second one. So the left side, there's nothing to do. So I'm just going to write the 4x minus 5 down is less than, distribute the 2, 4x minus 6. Okay. Notice that the coefficients are the same, but I'll go ahead and cancel them out to show you your statement here at the end. So we get -5 is less than -6. That is a false statement. -6 is smaller than -5. So since this is a false statement, that means there is nothing mathematically that will ever work. So all you do is an empty set, meaning you don't shade anything. There's no solution. So you just leave it empty. So to check it, sorry for the writing there. To check it, if you put in 0, it should be false because nothing, it shouldn't matter if I put 0 or 100 or 5,000 or a half, it shouldn't work no matter what I do. So the left side will never be less than the right side. So 4 times 0 minus 5 is less than 2 times 2 minus 0 minus 3. So 0 minus or times 4 is 0 minus 5 is -5 is less than 2 times 0, which is 0, minus 3 is -3, times 2 is -6. So go ahead and again, you can pause it, try it yourself or with your partner and see if you get the same answers I do, or if you want to watch me and go through the try it with me, you can. So on the left side, I'm going to distribute the -2, so I get -8x plus 4 is less than, and over on the right side, there's nothing to do. So notice that the coefficients on the x's are the same, but we're going to go ahead and add 8x to both sides. See that we get 4 is less than 4. Now, it looks, that's what we wanted before to be infinite solution, but unfortunately that is a false statement because 4 is not less than 4. 4 is less than or equal to 4, but this is not a false, or this is not true, so it is a false statement, which tells you it's a empty set. So that means you can go ahead and graph it, put your 0 on there, but there's nothing else to add to it or shade because it's an empty set. You can check the 0 just to check, or let's have a little fun. Let's check with 1. So -2, and then 4 times 1 minus 2. So 4 times 1 is 4, minus 2 is 2, times -2 is -4. That's supposed to be less than -8 times 1 plus 4. So -8 times 1 is -8, plus 4 is -4. Again, we get a false statement. So I know that it's empty. And if you want to check -10 and 10, -20 and 20, you can, but anything you check will have no solution. B, on the left side, there's nothing to do. So -6x minus 5 is less than, distribute the -3. So we get -6 is less than, I shouldn't say less than, sorry. Negative 6 is subtracting the 3. Again, you notice the coefficients are the same, but I'll go ahead and add 6x to both sides so we can look at the false statement or true statement. So we get negative 5 is less than negative 3. In other words, is negative 5 smaller than negative 3? And the answer is yes. So this is a true statement, which means that we have a set here. That is infinite. In other words, any answer, so anything I check here, I forgot to write up here, put no solution is the actual answer. And down here, since it can be anything, since it was a true statement, this would be infinitely many solutions. So again, I'm going to check, oh, we'll have fun. We'll just do a 2 this time. So we have negative 6 times 2 minus 5 shouldn't matter because any of these answers should work. Negative 3 times 2 plus 1. So left side, negative 6 times 2 is negative 12 minus 5 is negative 17. That should be less than 2 times 2 is 4 plus 1 is 5 times negative 3 is negative 15. And that is a true fact. Negative 17 is for sure less than negative 15. Again, you can check negative 20, 20, 100, negative 100, 0. It doesn't matter. It will end up with a true statement. So this one's a true statement, why it's a infinite many, and this one's a false statement, hence the reason why it's no solution. Last example here is going to be a storyline. So it says Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A and then from florist B? Let's see what we got here. Florist A charges $4.75 per blue rose plus a $40 delivery charge. That's a lot of money there. You'd hopefully have to buy a lot of roses to want to deliver that at a $40 price. And then florist B is $5.15 per red rose, but only a $25 delivery fee. I still think that's a lot, but the storyline is as is. So let's formulate. Since it's a storyline, you're going to go through your steps. So our formula, first thing I always do is figure out what X is. What's my unknown? What am I looking for? So if I go back up here and I look for my question, it says what number of roses? So X has to be the number of roses. Okay, so if I look up here, it says, for what number of roses is it less expensive to order from florist A than from florist B? So I'm going to set up an inequality that is going to test that idea here. So on this side, the cost of, we want the cost of, we don't know how many roses, but we'll go X roses at florist A. We want to know when that's less than, I'm writing too big, the cost of X roses at florist B. So that's the word behind it. So again, I got that from reading the question. I want to know what number of roses is it less expensive to order from A than from B. So I just wrote that. The cost of X roses at florist A, we want that to be less than the cost of roses at florist B. So let's go ahead and make our actual equation. So the cost of roses from A is $4.75 per rose. So that'd be 4.75x plus addition $40 delivery fee. We want to make sure that's less than, then over here, it's $5.15 per rose plus a $25 delivery fee. So we got our equation set up. We're going to go ahead and compute, in other words, solve. So I like to get rid of my x's first. Since this is a smaller one, I'll subtract $4.75 from both sides. So on the left side, I end up with 40 is less than $15.50. 15 cents minus $4.75 is 40 cents plus 25. And that 40 cents, which totally makes sense, sense, because they both, or I should say the difference between those two prices is 40 cents. Now I'm going to subtract the 25, the delivery fee. So 40 minus the 25 leaves me with 15 is less than that 40x, and then divide by 40 cents here. And by the way, the 15 makes sense because that's the change or the difference between the two delivery fees. So I get, check my calculator here, 37.5, since it's money, I'll put a 0 on there, is less than x. Again, if you don't like to read it that way, you can flip it. When x is greater than 37.5. Actually, it's roses, not money. X is the number of roses, so 35.7. Now, can you check this? Of course. Since this is, we can go back and see if it mathematically works. It's not a no solution or an infinite, so we can actually check it. So if you go back up here and plug in, we'll just put it in parentheses here, 37.50, 37.5 roses. So $4.75 times $37 or 37.5. I keep calling them dollars, roses, plus 40. So if you ordered 37.5 roses, which I know doesn't make sense, you are going to end up paying, I'll stick it over here, $218, and well, it'd be rounded, but I'll do the exact amount. It'd be 13 cents, but the calculator is 125 thousandths. Again, plug that same over here just to make sure we did our math right. So $5.15 times the 37.5 roses plus the $25 fee also equals that. So I know that my answer of 37.5 roses is right. Now that's when they're exactly equal, because that's when they both equal the $218 and, well, it'd be 13 cents, but exact would be 125 thousandths. Okay, now we've done all the work. The last part is to interpret, and I didn't leave a lot of room, but I'll try to interpret here to the side. So we're going to interpret. So our first question is, for what number of roses is it less expensive to order from florist A? If it's exactly equal at 37.5, that means we go either way. If we go 37 or we go 35. And since we had our inequality in there, we know that X is greater than 37.5. So if we're going to go, let's go with florist A. So if he buys, so since our inequality was a less than, so hopefully that makes sense. Since it was a less than, even though I got flipped when I wrote it again, but since X is, and our equality was less than, that means that A is cheaper if you buy more than 37.5 roses. And since you can't buy 37.5, we're going to say 38. So if Derek plans to buy 38 or more, maybe he wants to buy a lot of roses for his significant other or whoever, florist A is less expensive. Okay, a couple of reasons why I know that's true. Number one, my equation tells me that. X is going to be greater than 37.5 if this statement, to make the statement true. So remember, this is florist A and florist B, so it have to be greater than the 28. The other way, and if you remember slope from last year, the more roses you buy, you want it to be less per rose. And so right here, the more roses I buy, I'm going to go with Florist A because it's less per rose. Even though it has a delivery fee of $40, the more I buy, it's less per rose, which means that it'll end up cheaper in the end. Okay, and then the other side, I'll write it over here. If Derek plans to buy, and again, you can't have 37.5 is exact, to buy 37 or less roses, Florist B is less expensive. Okay, so hopefully that makes sense. So go ahead and pause it or just wait, I should say, or just watch me go through it and then see if you can get it right. So try it. Derek wants to order some roses online. Florist A charges $4.75 per blue flower and a $40 gift card. So the same as before. Florist B charges $15. Sorry, $5.15. It must be past 4. It is. Per rose plus $25 delivery charge. If Florist B increases the cost per rose to $5.20, for what number of roses is it less expensive to order from Florist A and Florist B? So same exact problem, except for this time, we're going to up the price per flower for Florist B. So let's go ahead and make our formula. Remember, X is the number of roses. So we'll go with figure out which one's cheaper. So we're going to go with Florist A on this side. So it's $4.75 per rose plus a $40 delivery fee. Want to know when that's less than. Now this time it's $5.20 X plus 25. Go ahead and solve. We'll see if I can write a little smaller. So we're going to subtract the little guy. So $4.75 from both sides. We get 40 is less than, let's see here, 45 cents. What's the difference in price between their two roses? Then subtract the $25 delivery fee. 40 minus 25 is, losing my mind here, 15, which is less than the 45 cents. Divide by the 45 cents. So 15 divided by 45 cents would leave me with 33 1/3 roses, which is less than X. Or I like to flip it around, X is greater than 33 1/3. So this time, if you plug in 33 1/3, so if I plug 33 1/3, you'll get the same thing on both sides. Let's go ahead and do that. So if I plug 33 1/3 roses, so I'm going to take 4.75 times, well, in my calculator, I'm going to put it as a mix or an improper fraction. So that'd be 100 divided by 3 plus the $40. It'd be $198.33 repeating cents, or in other words, $198.33. On the other side, $5.20 times the 33 1/3 plus the $25, and I get the same thing. So I know my answer is correct here. So that's when they're exactly the same. If you buy 33 1/3 roses, you're going to pay $198.33, no matter what. But the question was, I set it up as when is Florist A, remember this is A on this side, less than B? And the answer is when X is greater than 33. So that's my interpretation for the A. I'll put it over here again. So my interpretation is, if Derek buys, now you can't buy 33 1/3, that's when it's exact, so we'd have to go one up, around up here to 34. So if he buys 34 or more roses, he would go with plan or Florist A. And then the opposite, and I could do the problem again, I would just flip the sign to greater than. In other words, I want to know when it's better to go with plan B. And of course, that since this is equal, you'd go down. You'd shade to the left. So if Derek buys, yeah, 33 and a third is exact, we're going to go down to 33 or less. Then florist B is less expensive. Hopefully that helps. If you have any questions, go ahead and email me. I will have my phone with me. I'll get back to you at some point during the day. And then go ahead and get your Math Excel done. It is due tomorrow at the beginning of class, and we will be taking a quiz. But before we take the quiz, I will make sure to answer any questions that you still have about inequalities. Have a great day.